Welcome to EDU-VALUED Academy, where education is evaluated. Today, I will have a class of motion. Motion is a relative phenomenon. The whole world is moving since the earth is moving around. We did not consider now initially the reference frame. Later, we will consider reference frame also. First, motion contrasting situation is rest versus motion. What do you mean by rest? We see there are many things standing still, houses, trees. Since they do not move, they are at rest. They are not changing their position, their shape, their size, their direction. So anything that is not changing its position or direction or shape or size, they all are at rest. The opposite to rest is motion. It implies if anything changing its either position or direction or shape or size, then those quantities are in motion. When we switch on, fan moves. Earlier it was at rest. When switched on, the fan starts moving. It starts changing its position and direction with respect to time. So things which are not changing either state or direction or position or shape or size, they are rest, and if they are changing direction, position, shape, size with respect to time, here time is a factor. That is the reason we will nurture today physical quantities like distance, time. These are the primary physical quantities which will help us learn speed, velocity, acceleration, retardation. These physical quantities are the secondary quantities. They are depending on distance and also time. My next point is scalar and vector. These are two important physical quantities. We have two physical quantities, either they are scalar or vector. Let me briefly explain these quantities. These are two physical quantities, scalar, having only magnitude. There are many quantities for which you do not need any direction. When you go for weighing 5 kg potato, 5 kg sugar, when we go for measuring length, 5 meter, 10 meter, these quantities do not need any direction. So the quantities which are having magnitude as well as direction both, like if I want to write something on the board, I have to take a pen, I have to change my direction towards the board, and then I will write. So for writing sake, I have to take the direction towards the board if I want to write on the boards. Then a specific, if I go arbitrarily anywhere, I cannot write on this board. When we do some work, we use force, muscular force normally. If I want to lift a weight, I have to take it up. Like this is the bottle, I'm giving up. So this is, I'm lifting up, having a direction towards north. So this way sometimes we apply force in a particular direction, then only work will be done. So the quantities which have both magnitude as well as direction, they are vector quantities, and those quantities, physical quantities, normally what we do in our day-to-day life, like we weigh our goods, we count many chocolates. So this for counting, for measuring length, for weighing weight, we do not need any direction. So those quantities which have only magnitude, like kg, gram, meter, these are all pound, these are all physical quantities, and they do not need any direction. If I want to go north, if I do not maintain the direction towards north, I cannot reach there. So for particular direction, if I follow, then that quantity will be vector quantity. Let me discuss regarding scalar and vector. Here is an example of scalar, that is distance, and the example of vector is your displacement. Now let me define these two quantities, distance and displacement. Like distance, when we go out of our home, we take many routes to reach our destination. Normally, it is the quantity distance, we travel distance, total distance, like if I start here and then if I go this side, this way, this way, this way, this way, and this total length is your distance. This total length traced by an object, like an ant is moving like this. So this movement, whatever the length this ant traced, is total length is your distance. This is your distance. But if I say I am going towards east 5 meters, this distance I have traveled in a particular direction. So when we are maintaining the direction and 5 meters, this quantity is displacement. So this displacement is a vector quantity, because displacement, distance measured in a particular direction. We cannot measure this direction, this distance in any direction. Like here, you see, this is not that way maintaining any direction. So this whole distance, the length traced by an ant is your distance. Whereas if an ant moves from here to the east direction, towards east, 5 meters. So this distance, since it is in a particular direction, so this is your displacement. That is the result. It's SI unit, standard unit for distance and displacement. Both by magnitude it is meter. But one is not following any direction, other one is following a direction, particular direction. When it is a direction, it's a displacement. And it is a vector quantity. When it is traced, this length is traced in any direction. Like when we go out of home, we normally follow zigzag paths. We do not maintain a straight path. We have to take turn, then we move for some time, they again take turn. So this way the distance we move is a distance, not displacement. Because we are not following any particular direction while moving. Even though on vehicles, when you go, we sometimes move haphazardly without maintaining any direction. So definitely that is we are covering distance, not displacement. Displacement is the shortest distance between the initial and final position. Like if this total quantity is your distance, then only displacement will be this one. This is the shortest distance. This shortest distance is known as displacement between the initial and final position. That means we are measuring this distance in a particular direction to measure this smallest distance, the least distance. And here, this is your distance. This is your distance, and this quantity is your displacement. Here, this is the distance between the initial and final. The shortest distance between the initial and final position is the displacement, whereas distance covered is this much. The same way, like if an ant is moving in a circular direction, like halfway of circle, this is, let's say, half semicircle, let's say, and an ant is moving like this. Here it is stopping. If I ask, what is the distance and what is the displacement? Displacement, obviously, we know this is your, if it is, the radius is r, so this is your pi r. 2 pi r circumference and the half of 2 pi r is pi r. This is the total length covered. Sorry. So this is your distance and displacement is your 2r. 2r is your displacement. This is the diameter. This is the shortest distance. This way we say, I can say a person getting out of bed and again going to sleep at night. At the same bed, on the same bed they lie regularly. So total day they have come across many distances and then finally they are going to sleep on the same bed. So their displacement will be obviously 0 because they are coming back to the same point. The total day, if I consider, they are going out, they are moving, they are going to school, they are going to play and then coming back, and then when they are finally coming to sleep on the bed, same bed they left in the morning, so definitely the final and initial position coincide. This coincidence gives us the 0 displacement. Whereas the distance is long distance they might have covered, but the total displacement will be 0 for this. So this way we have these two quantities, distance and displacement. One is a scalar quantity, distance, and displacement is a vector quantity. With the relation distance and time, this is speed, it is also a scalar quantity, and displacement with time, this is your velocity, it's a vector quantity. That means these two are the combination of distance and time. Distance and time both. Here distance, normally we take s, this is your t. So these two are quantities are the secondary quantities. Speed, distance traveled by an object in per unit time. In time t second, let's say t second, a body moves s distance, s meter distance. Let's say s meter distance is travels. So in 1 meter, 1 second, in 1 second it will cover s upon t. And this is unit time, it is traveling this distance. So the distance traveled in per unit time is known as speed. So speed is equal to distance upon time. Speed is equal to distance upon time. So it is clear, I think. The distance traveled by an object in per unit time is called speed. It is your distance upon time. So this is distance is measured in SI unit meter and time second. So this SI unit of speed is meter per second. Now let me talk about displacement. With time, that will give us velocity, because velocity is a vector quantity. It has to maintain a direction. So again, if an object covers in t second, in t second it covers, let's say ki s meter distance in towards north in a particular direction. That means distance traveled in per unit time in a particular direction. This is called your velocity. That means velocity is a speed in a fixed direction. I can say if speed in a fixed direction, that is known as velocity. That means for velocity we need a particular direction. If an object covers a distance in per unit time in a fixed direction, that is called velocity. So that, but the velocity is also displacement upon time. Velocity is displacement upon time. SI unit is same. This is meter. This is second. So for both cases, for the case of magnitude, they are the symbol meter per second. So SI unit of both speed and velocity, meter per second. But velocity is a vector quantity. It is distance traveled by an object in per unit time in a fixed direction, or displacement traveled by an object in per unit time. Displacement is already including direction. That is the reason we can say displacement traveled by an object in per unit time is called velocity. So now we have come to know these two quantities are different. Distance and displacement are two different quantities. This is a scalar, this is a vector. Now coming to our fifth point, that is your acceleration and retardation. Initially, we have got speed and velocity. It is the changing position with respect to time or covering distance, whether it is in a direction or not in a direction. In per unit time is either speed or velocity. Now acceleration. Acceleration is also a secondary quantity. The acceleration is also a vector quantity, because in an arbitrary direction they cannot change their velocities. So the rate of change of velocity in per unit time is called acceleration. That means velocity is equal to displacement upon time. Displacement upon time, and acceleration is your velocity upon time. This is obviously change of velocity upon time. So the rate of change of velocity in per unit time is called your acceleration. This I may write v minus u upon t. How? Initially the velocity was u. After t second the velocity changes to v. So the change of velocity is what? V minus u. In time t second, the change of velocity is v minus u. In per unit time, this is v minus u upon t. So the rate of change of velocity in per unit time is called your acceleration. And acceleration is also a secondary quantity. It is the two quantities already are there, velocity and time. Velocity itself is a secondary quantity. It is depending on time and distance. So acceleration v minus u upon t. If this acceleration, in the case of here u is less than v, u is less than v. If I say v is less than u, if v becomes less than u, so this quantity will be negative. When we apply brake, the velocity is reduced. Then the rate of change of velocity will be negative. And that negative acceleration is known as retardation. This retardation is nothing but the negative acceleration is called your retardation. Now I hope you have understood these physical quantities regarding motion. One is the main primary quantity is your distance, time. The secondary quantity is speed, velocity, acceleration, retardation. Now here is the last point, that is called reference frame. Why it is needed, reference frame? You think you are traveling by train. While traveling by train, the passenger who is sitting beside you, you may feel they are not changing. Like you are not changing your position and he is not changing his position. So the relative position of both of you are same. That is the reason you are feeling you are at rest and your passenger sitting beside you, he is also at rest. But originally you two both are not at rest at all. The whole train is moving. So this is the reference frame. In the reference frame of the compartment, you two are at rest. Other things, whichever is outside, they are all in motion. Even they are standing, they are not in motion, they are at rest. Even the trees will seemingly moving, passing away, and you will feel you two are at rest and they are in motion. But actually, you are in motion and the trees and the grounds are at rest. So it is a reference frame that changes the vision. Likewise, we all are in motion, but normally when I am standing, I say I am at rest, but our earth is moving. But in this reference frame of this room, obviously time is passing away, nothing is changing, everything is as it is. So they are at rest. So this is called reference frame. In which reference frame we are considering, it does matter. Like when two trains are traveling with the same speed in the same direction, a passenger sitting one in one train, another sitting in another thing, if they are parallelly moving, they will feel no, both of them are not moving at all. Even both are moving. So this is the reference frame of that particular situation. You are seeing from a moving train, and that is also moving. So if that is relative speed will be 0, and you will feel the person is not moving at all, and he also will feel you are not moving at all. So reference frame is also important for considering physical quantities. Okay, I hope you will try to understand these physical quantities. If you feel good, you share among your friends, and also you try to understand this clearly. If you don't understand, you write, and if you feel good, like and subscribe my channel to have, and also the bell icon is there. Press that bell icon to get my videos as early as possible. Whenever I will release, you will get that video. Thank you. I hope you will be knowing well of this WhatsApp. Thank you.